how to open the QVD file means need to go to QlikView. As it is a data file, you can directly go to table files because QVD is nothing but one data file. Go to table files, select here insurance QVD employee.qvd, open. If you see here, all the data is stored into this QVD file. Levels, next, finish and reload it. So just to remove this relative path and try to load it. Select here table files, employee QVD, next, embedded labels, finish. So now you can save it and reload it. So automatically all the data of that employee table will be stored into this QVD file. So this is how we store the data into the QVD file by using the store command. Store table name into this one. Like that, if you want to store any number of tables, you can store it into QVD. So suppose I want to load another table. So department table also I want to load means, again I can take one new tab, click on select, here I can select my Scott user, department, click on OK. I can give some department table and I can store it into one QVD. Store DEPT into the path where you want to save your QVD. So I will be saving in the same path with different name. So as it is a department table, I will load with department.qvd. Save and reload. Like that you can store any number of tables. Suppose if see here this department QVD is employee QVD, you will be storing the data into QVD like this. So this is the concept of QVD advantages and relative path, absolute path and include files and how to connect to the relational databases. So next we will see about the different loads available in QlikView. Available in QlikView. Different kinds of loads. First one is inline load. Next one is preceding load. Next one is resident load. So these loads we will see each and every concept when we are moving. Resident load. Next one is incremental load. Awesome. Incremental load, partial load, binary load, generic load and buffer load. So these are the different kinds of loads. So this inline load, preceding load, resident, incremental, partial, this binary load, these are very important. And this generic load and buffer load, we are not that much useful. We mainly use this one. So we have already covered this preceding load. If you can see here, while storing the data into QVD, whatever the load statement is there before this SQL select star, whatever this load statement, this is called as preceding load. Suppose I will take here one more tab and I will click on select. So I will select the Scott user. Under that user, now I will select some salary grade table. If you can see here, this is the preceding load. If you uncheck this option, you will not get the load statement before this SQL statement. So in order to get that load statement, we normally use here preceding load. Check this preceding load. Click on OK. Okay. So this is how we use that preceding load. So for now, next we will see what is this inline load and resident load, incremental load. While we are covering other concepts, we will cover there. First I will see about this inline load. What is this inline load means? In QlikView, whenever if you want to enter some user defined tables, so you want to enter the table, you want to create the table at QlikView level. So normally we will pull the data from databases, but instead of that one, you need to create the table at QlikView. In the QlikView itself means you can create your own table in QlikView. So how you can create means, go to this scripting part and go to insert here and click on load statement and click on load inline. This will open, and here you can derive the column names and you can create one table. So I am creating one employee ID column, employee name column, and one salary column like this. And if you want to enter the values, you can enter the values for that one. Employee ID 123, employee ID 234, 300, 768, 400. Just like that you can create one table at QlikView itself. Click on save it with some name and reload it. So automatically one table will be created. So these are the values of the table. So how that inline load will be means, in the scripting, whenever if you see this kind of load star inline means, this is nothing but inline load. This is the table created at QlikView level. So this is how we create the table at QlikView part. So next we will see about so we have covered about the QlikView data modeling concepts. So what we will do means, we will design one data model. We can design a star schema model or snowflake schema model, and we can see the data modeling how it will be. Suppose I'm having one file like this, manual files. So this is my database. It is one of my Microsoft database, MDB database. These many tables are there, and this is my schema model. So I need to build this kind of one data model in QlikView. Okay, so we will already, you know how to store the data into QVD. Each table is already stored into one QVD file. Already all these categories table, customer tables, division tables are all already stored into QVD. Now what is your requirement means, based on this diagram, based on this relationship diagram, we will start to build one QlikView data model. So we will build this data model. While building this data model, again you will be getting some issues like synthetic keys and circular reference. So that you will see how we eliminate and how we finally build one data model in QlikView. So I will take this, all the tables already it's stored into QVD files. So all these QVD files are there, like customer, categories, divisions table, everything are there in the QVD files. So we will start building one new data model like this. So it is nothing but one of the snowflake schema data model. This data model we will build. So first table is customers table. So take one new fresh QlikView dashboard and click on this edit script on the top, and now start loading your all the tables. So first table, what is your table? See this diagram, customer table. So try to load the customer table. So you can rename this tab. Normally we will give your same name of your table, customers. Load the table. So is it a QVD file? You can directly go to table files, select here this one. Under this insurance folder, under this QVDs, I have customers table. So customers.qvd. Select that QVD, click on open, next. So select here embedded labels in order to get exact column names. next and finish. So first remove this relative path here, save data model, try to load the customers table. Click on finish. Now you can rename it as to customers table. So normally you'll give the table name. So load the customers table. So first table is loaded. So nothing issues, no synthetic keys, no circular reference. Now try to load the second table called as orders table. So click on the script, take here new tab, this one, name it as orders. Try to load the second table, orders. Embedded labels, click on the next and finish. So I name it as orders table. Click on save and reload. So second table is loaded. You are not getting any synthetic keys, so your data model is fine. So go to your diagram. Next table is your divisions table. Load the divisions table. Click on table files, select here division .qvd. Division, click on save and reload. Next, this is the divisions table. Now your data model looks fine, no synthetic keys, nothing. Next, load the order details table. Order details, table files, order details, next, order labels, finish. Order details, save and reload. So order details table is loaded. So your data model is fine, no synthetic keys, nothing issues. Next, you try to load the next table. Next one is shippers table. So go to this tab, add new tab. Name it as shippers table. Table files, shippers, open, embedded labels, next and finish. So we'll name it as some shippers table like this. Click on save and reload. So now see here you got one error. So if you get this kind of error means you got circular loops in your dashboard. So why you got means you can see this one, customers table and orders table and shippers table, there is a loop here. These three are forming a closed loop. So why means because this shippers table is again linking to the customer table on company name. So this company name you can automatically rename it, or you can remove it if it's not required. So I want the company name, so that's why I will use here rename method, and I will remove my circular loops. So now like that you will solve the circular loops when you are building the data model. So now your data model is fine. Next we will move to the next table here called as shippers table. Next one is the products table. So I am trying to load the product table here. So click on OK and go here for loading the product tables. Products table files, load the product QVD. on save and reload. So if you can see here, if you see here, you got the synthetic keys here, because between the order details table and product table there is a product ID and unit price as a common column. So more than one common column is there. So that's why you got here one synthetic key. So here if you see here, what method you can use here means based on these fields you need to analyze here. So I am having product ID and unit price as common column. So one is a dimension column and another one is a measure column. So normally measure columns will not be used as a key for joining the two tables. So in this scenario we can directly use the rename method, because measure unit price is a measure column which is another common column. So you will not be linking on that column, so directly you can rename the price column to U price or something. Click on save and reload. So now finally your synthetic key is removed and it is linked to the order details table on the product ID. So like that, based on that what columns, what are the common columns and what kind of columns are there, that also you need to analyze, and you need to remove your synthetic keys by using this any of these tables like this, unit price or anything like that. I have removed here because here rename is a better method. Next, if you see your data model, next you have one more two tables called as shipments table and categories table. So next I will load those tables. Shipments table. So load the shipments table. Go to table files, select here shipments, click on next, number labels and finish. So you can name it as shipments like this and save and reload. So if you see here again, you might be getting circular loops here, and if you see the data model you will get confused exactly where the synthetic key is coming. So here if you go to your diagram here, order details and shipments table are linking on order ID and product line number. So here order ID and line number are the two common columns, that's why you got synthetic keys. So but here you cannot use rename method, because this also can be a key column, this also can be, you can be using as a key column. So key columns you cannot directly rename and you cannot use that rename method here. So here I will tell you how to use that qualify unqualify method. So when discussing about that synthetic keys, I was telling that I will discuss about the qualify and qualify method while working on this data model. So that method I will use here. So how we need to use means, we have first we need to use one qualify function here, qualify star like this. On that table you need to use this command called as qualify star. After this you save and reload your dashboard. So after using that qualify star, and if you save and reload your dashboard, automatically it will remove the synthetic keys and it will generate one more table here like this called as shipments table. This table will have with table name dot column name, it will derive the one table like this. So what does qualify function will do means, once if you give qualify star means it will remove the synthetic keys and it will form a separate table for that, whatever the table before that you have given that qualify, that table it will derive with table name dot column name like this. So now what is your requirement according to a data model? You need to link this order ID and line number to the shipments table. So if you want to link means, you need to combine this order ID and line number and you need to generate one composite key, and then only you can link this order details table to the shipments table. So for that what I will do means, here I will create one composite key in this one. I will add line number and order ID as S key or something. So here I will remove the order ID and line number, because again if I have, I will get again synthetic key. So this order ID and line number I will have in the order details table, which table you are linking. Okay. So after this, if you click on save and reload, still your order details table will not be linked to the shipments table. Still you have this S key is the column and here S key is the column. So this key and this key must be linked to these tables, because as there is a shipments before that S key column, it is not linking. So in QlikView, whenever if you want to link one table to other table, the column name must be same, but here it is S key, but here it is shipments.S key. So what you need to do here is, means we have one unqualify function in QlikView. You can unqualify that table name before that particular column. So give here unqualify and the column name S key. So what it will do means, only for that key it will remove the table name dot column name in that one. Click on unqualify, click on save and reload. Now if you see here, if you go to shipments table, only for that column, before that column name shipments was there, now it is not there. It will show me only as S key. So automatically your order details table is linked to the shipments table on this S key column like this. So like this you will use this qualify unqualify method and you will remove the synthetic keys like this. So first what you need to do means, once if you get synthetic key, use this qualify star function. So this will automatically remove the synthetic keys and it will form a table with table name dot column name. Next what you need to do is, you need to create one composite key for linking this table to the other table, because you need to link this order details to the shipments table. So for linking that, you are creating one composite key and that key you are copying to the order details table, and after if you reload, you will not get the join between this order details and shipments key, because there will be a column table name dot column name for this key. So in order to remove the table name, you need to unqualify for that particular key. You need to use unqualify and S key, and finally your data model is fine. And one more table is left. We are here. The final table is categories table. So try to load this categories table now. Cancel it. Go to tabs, select here CAT GORIS categories, and now go to table files and select your finally categories QVD. Categories, open, next, finish. CATGORIS categories. Now see here, if you click on save and reload, according to your data model, this categories table must be linked to the product table on this customer category ID. But if you see your data model, again it has derived one more table with table name dot column name, because still we have that qualify function. So we have used one function called as qualify function here. So if you use this qualify function, means whatever the tables you are loading after this qualify function, for all the tables it will derive like this, some separate table. So you need to close that qualify function after using that one. So how you need to close means, because you don't want the qualify function to be applied for rest of the tables, you want only for this table. So that's why under this end of the script you need to unqualify it. Unqualify start means close this function here itself and don't apply these functions to the other tables. This function. Click on save and reload. Now finally your categories table is linked to the product table on category ID. So now we have built one snowflake schema model like this. Finally we have built one data model like this. So after building the data model, they will give all the front end requirements, what and all they want in the front end. So that front end requirements you can take and you can start designing the front end. So I will take here some multi boxes like this. So next we will start building the front end design like this. Based on the requirement we will start here. Now I will show here, after building this dashboard, suppose if you see one of our developer dashboard, this we call it as master calendar of your dashboard. So we have here year, quarter, month. So normally on the top of the dashboard we maintain this kind of master calendar. So why means, so user will select for particular year, particular quarter, particular month, what is the sales, like that. If you want to analyze, you can design this master calendar on the top. So how we design this master calendar means, for our dashboard also, based on whichever is your main date column, on that date column we can derive this master calendar. So if you see for our table, I think in order table I am having order ID, order date. On this column I will derive the master calendar and I will put it in the front end. So how means, first I want year, how many years data it is showing. So that's why we will use here order date, year of order date as order date. Next we want to derive the quarter. So for deriving the quarter you need to use one function here. You need to give Q and symbol, and you have one seal function, seal of month of order date as quarter. Like this you can derive the quarter. So how this function will work means, you are giving month of order date. So month of order date means, if it is first month means it will give the value as month of order date divided by 3 here. Like this you need to give. So what month of order date divided by 3 it will give means, suppose if your month name is 1 means 1 divided by 3 means automatically it will come around 0 point something. So what seal function will do, 0 point something means it will automatically round it to quarter 1. So normally month 1 is quarter 1. Suppose if your month number is 4 means 4 divided by 3 means it will come around 1 point something. So 1 point of seal means it will automatically go to second quarter. So automatically fourth month will come under second quarter. Like that it will calculate the quarters. You can give your order date divided by 3 here itself. This is how you derive the quarter. Next you want to get the month. You here month of order date. Next week, you need to get the week. So like that we have many things like week number, week last day. We normally give here week and day of order date. Click on save and reload. Automatically must be in 1 minute. I have given one column name different. So this year of order date I need to give it as year, not as order date. Save and reload. So now you got year and quarter. So you can arrange your master calendar on the top. So for that I will take one list box and I will give here year column. So if you represent in this vertical format, it will occupy more space on your sheet. So you need to arrange it in horizontal format. How you arrange this into horizontal format means, go to this presentation, remove this single column, order by column, click on apply, click on OK. So like this it will come in horizontal. You can drag it and you can place it here like this, here. Next you want it as quarter. Take another list box, add your quarter column. So here you need to give month of order date divided by 3. So now you got here quarter 1, 2 and 3 and 4. So go to this single column, order by column. You remove these two options, click on apply, OK. So it will show in horizontal format. Like that, next we can add the month names. Go to list box, month, OK. So go to this properties, under presentation, remove this single column, order by column, apply, OK. And you can arrange it like this. So I got year, quarter, month. Next you can add week also. take another list box, add the week numbers, total weeks of that year it will show. You can go properties, presentation, you need to uncheck these two options, so it will give me the week numbers like this. So now if you see here, I will add one more table box and I will add the data. So by using this master calendar, user can select for particular year, particular quarter, quarter one, for particular month, for particular week, what is the sales, like that. Based on the, he can select the master calendar and he can visualize the data. That is the use of this master calendar, how we derive in the front end. On the top of the dashboard we can give. If you want day also, you can add in the day. I have one more thing, day. Day means all the days of a month also it will show. Day 1 to total days it will show. I will go properties, presentation, single order by, I will click on apply, click on OK. So this is all the days. Normally we will have year, quarter, month, week and day, and he can select for quarter 4 particular month, so for 49th week, and in that week what is the date, what is the sales, like that. You can analyze by using this master calendar, how we derive and how we use this master calendar. This is how we derive the master calendar in the scripting part. So next we will see here one more requirement for this master calendar part. Suppose see here, normally quarter 1 means it will come as January, February and March. Quarter 2 means it will come as April, May and June. And quarter 3 is July, August, September. Quarter 4 is October, November, December. Some users will ask, they want quarter 1 as April, May and June, quarter 2 as October, November or December, like that. Like that if they ask means, you cannot, normally quarter 1 will be like this. So there you need to use the inline load. So recently we have discussed inline load, where you can create one table by yourself. So that is a user defined requirement. So that's why you need to create one table here by using the inline load. So go to insert here, click on load statement, select here load inline and give here quarter field, month field, first one, and next one is quarter. So month is, first one is January and February, like that you can give. So this one I want it as quarter, normally it is quarter 1, I am giving here quarter 3. So instead of here entering the values, you can click on this and from here onwards you can enter very easily. And next one is March, this one I want it as quarter 3. Next one is April. So April, May, June and all I want it as quarter 1. Quarter 1. Next one from July onwards, I want it as quarter. July, August I want it as quarter 4. September, quarter 4. And next one finally October as quarter 2. October, November and December. Quarter 2. Now click on save and reload. If you can see here, now if you click on save and reload, you are getting month names double time. So what you need to do here means, you first comment this quarter, because this quarter is not required for you, because already you have quarter derived there, comment it, and you need to use one trim function before this month. Why means, because here it is showing the two names here. So if you use trim means it will remove the space and you can get only one name. So just use here trim of that month, remove the spaces, click on save and reload. Now if you see here, you got only one month names. Now if I select quarter 1 means automatically it is showing me June, April and May, because quarter 1 is June, April and May. Quarter 2 is December, October, November. So like that you can change your quarters according to your user requirement. So we have covered the data modeling. So next we will see, if you will take the new sheet here, I click new sheet object. So still we have not discussed about this charts. So here we are having around 13 charts. So we'll see what is the use of each and every chart, what are the limitations of each and every chart. This we will discuss. First I will note down what and all are the different charts available in QlikView. Charts. So charts are very important whenever if you want to design your front-end designing. 80% of the designing will be done by the help of this different charts. First chart is bar chart. Next one we have line chart. Next one is pie chart. Combo chart. Gauge chart. And next we have this straight table, pivot table, and we have scattered chart, grid chart, Miko chart, block chart, radar, and funnel chart. So these are the 13 charts available here. So whatever you have seen in this one, I click new sheet object, charts. So these are the 13 charts. So whatever first I have showed about this bar chart, line chart, so this first 7, these up to this 7 charts, these are very important charts which we frequently using. So other charts like scattered, grid and all, we Mako, block, radar and all, based on some rare requirements we will be using these charts. So first we will discuss about this main charts, bar chart and everything, what is the requirement and all everything. So before going to this any kind of charts, whenever if you want to design anything, if you want to design with charts, means compulsory we need to have one dimension and expression. Only with dimension, only with expression you cannot analyze anything with the chart. So you need to have dimension and you need to have expression, so then only you can analyze something in your chart. So out of this all charts, there is only one chart which has only expression without dimension. It has only expression without dimension. That chart is called as gauge chart. Gauge chart is the one which is only having the expression without the dimension. Rest of all other charts you need to compulsory use dimension and expression, then only you can design your dashboard. Apart from these 13 charts, we have 3 more charts which will be available. Next one is about this mini chart. Mini chart is there and waterfall chart, and trellis chart. These 3 charts are the trellis. So this trellis chart will be there in all the charts. Again we have one more option called as trellis chart. So mini chart will be available again in straight table. In straight table you will find this one more chart. Inside that straight table you will find one more chart called as mini chart. So it will not be available in any other chart. And waterfall chart, using bar chart only we will design this kind of waterfall chart kind of representation. So these are the charts. First I will tell you each chart will have some limitations, because we cannot use any number of dimensions and any number of expressions, and you cannot design your charts. So first one, bar chart, how many dimensions you can use and how many expressions you can use maximum, we will see. And whenever if you want to use particular chart, you must be able to know when you want to use. Suppose they will give some requirement, so there you need to use bar chart or line chart. How we will decide means based on what they are expecting. Suppose bar chart means whenever if you want to compare the data, means if you want to compare some data, comparison purpose. Suppose you might be showing some 5 years data and you want to compare how the data is there from current year to previous year and other years like that. Means for comparison purpose we normally use the bar chart. So how many dimensions and how many expressions you can use it? You can use maximum 2 dimensions with 3 to 4 expressions like this. So maximum is 2 dimensions only. If you can use more than 2 dimensions, means in your bar chart you can use that dimension, but you cannot analyze anything by using that chart. 2 dimensions and 3 expressions. If you are using 1 dimension, means you can use here about some 7 to 8 expressions you can add into that. 7 to 8 expressions you can add in a bar chart. This is the limitation of this bar chart. So this bar chart limitations will apply to line chart and combo chart also. So when we use line chart, means whenever if you want to identify the change over a period of time, identifying the change over a period of time. So how over a period of time, how that is going, whether it is increasing or decreasing, like that. If you want to identify the trend, we will use the line chart. So if I will show one of the sample dashboard which will have mainly about these charts, we'll find here. So this is the dashboard which will mainly explain about the different kinds of charts here. So first one is comparison purpose. So this is the bar chart here. Whenever if you want to compare the data, we normally use a bar chart. Suppose here these are the different months. For different month he is showing some sales amount like this. So if you want to use for comparison purpose, we will use this bar chart. Next one about this line chart here is, this is the line chart how it looks. So if you want to identify the change over a period of time, means from 2007 to 2009, how for each month how the sales is going, whether it is increasing or decreasing, like that. If you want to identify, we will use the line chart. Combo chart means if you want to have the combination of both line chart and bar chart in one chart, means we will use this combo. It is a combination of both line and bar chart. So when we use this, means suppose you have some actual versus budget, otherwise actual versus target, like that. If you want to compare, suppose your target amount to be achieved is around some 200 sales, out of that actually you have achieved only 100. So if you want to compare what is the actual budget and what is the target you have achieved, and if you want to compare, means we normally use the combo chart. So how that combo chart looks, means if you see here, this is the combo chart. So actually this was your total target, and out of that you have achieved only this one. This is the target, out of that you have achieved only up to this part, like that. You want to compare, means we normally use the combo chart. Here also the dimensions and limitations will be the same. Next comes this pie chart. What is this pie chart means? Pie chart, whenever if you want to show the data in the form of ratios or percentages, if you want to show in ratios and percentages, we will use this pie chart. So what is the limitation of this pie chart? Means only one dimension we can use. We can use up to 3 expressions, like that. So number of dimensions if you can be using a pie chart is only 1 dimension you can use. So how the pie chart looks, means, so ratios, whenever if you want to show in the form of ratios with pie, means we normally use this pie chart. So next chart is important chart about the gauge chart. When we use the gauge chart, means for showing the KPIs. KPIs means here key performance indicators. Whenever if you want to show key performance indicators, we normally use here gauge chart. So what are these key performance indicators means? So whenever if you see the chart, by seeing that chart only you will be able to recognize what that chart is showing, something like that. Suppose if you want to show the margin, or otherwise if you want to show the sales profit, something like that, if you want to show in the chart means you can directly take one guide chart and you can show in that. So by seeing that only user can analyze what is the margin, whether he has achieved good margin or very less margin, like that. If you want to analyze means you can use this gauge chart. How it looks means, suppose this is a KPI here, this is one of our, these are different representations. This representation we mainly use in a gauge chart. So these are red mark, yellow mark and green mark. So automatically if this meter is showing in the red region means you can come to know that margin is very less for the whatever it can be, for the products or whatever you are selling, the margin is very less. So like that, by seeing the chart only we can recognize what it is. So by seeing this chart only, if it is red means we will come to know that margin is very less. So like that we can identify. That's why we call it as key performance indicators. So that we represent in a gauge chart. So next comes here about the straight table and pivoting table. So these two we have some main, we can compare mainly the straight table, pivoting table later. Next we will see the other charts, and finally we will see this straight and pivoting table where we use. Next is scattered and grid charts are. Grid chart means whenever if you want to show some relationship between the data points, relationship among the different data points. So we use this grid chart, either it can be a grid or scatter chart. Relationships if you want to show means we will use this grid chart. How it looks is, this is one of the, this is grid chart. So for different years and for different quarters you are showing the different region sales like this. You are identifying the relationship among the data points. Here also you are doing same, but here the representation will be a different like this. This is about the scattered and grid chart. Coming to these limitations of the scattered and grid chart. Grid chart means we need to have minimum 2 dimensions. If you have only 1 dimension means you cannot analyze anything in a scatter chart. Minimum you need to have 2 dimensions. Max you can use up to 4 dimensions. So if you use 1 dimension means in a scatter chart you cannot get anything. You will get the error if you use 1 dimension in a grid chart. Minimum is 2 dimensions and for maximum is 4. Expressions also we can use up to 4 expressions in a grid chart. Scatter chart is quite opposite. You need to have minimum 2 expressions. If you have 1 expression you cannot analyze. Minimum 2 expressions. And maximum we can use 5 expressions. Dimensions means maximum 2 dimensions we can use in a scatter chart. So this is the limitations of this chart, how many dimensions and how many expressions you can use, and you can analyze the data. These two charts are another combination. Next, this Meko and block, these two charts are the next combination charts. This also will be the same, only the representing part will be the difference between Meko and this chart. So what did that representation will be means, if you see this dashboard ratios, this is nothing but your Meko chart. So you are showing the different region wise, product wise, different region wise, some sales amount. So whatever the sales is there, that it will be showing in the width kind of form, that the presentation. Whereas a block chart is, it will be the same, but it will display you like that. Even the name of that particular dimension value will be displayed inside the graph. That is only the difference between the Meko and block chart. Both will be the same. Only the presentation of the view of the dashboard of that chart will be different. This is Meko and one. Next other two charts here is radar chart and funnel chart. So these we rarely use. Some users, if they ask in radar representation, so if they want to see in this kind of representation, so this radar kind of representation, if we want to show any images, there we use this radar chart. And funnel chart means if you want to show in some funnel kind of representation, this kind of form, we will use this funnel chart. Is that? So here it's not there. You can see here in the data model. So this kind of form, if you want to see the data in this V kind of representation, if the graph model means, we normally use the here funnel chart. So these are about these charts. So now I will tell you what is this straight table and pivoting table. What are the differences between straight and pivoting table? Again, this straight table and pivoting table, there is no limitations on how many dimensions you can use and how many expressions. You can use unlimited number of dimensions and expressions, and you can analyze the data. Then what is the difference between straight table and pivoting table? Means whenever if you want to sort the data in a table, sorting data, we use straight table. And for whenever if you want group wise data, group wise data, we will use here group wise data, we will use pivot table. Next one is whenever if you might be having one dimension limits option. Means if you want to restrict on dimensions, dimension limit option is there in straight table, and it is not there in a pivoting table. Dimension, based on dimensions, you cannot limit your data in pivot table.